A very good morning to our beloved lecturer, Dr. Ashraf. We are from Group A, and today we will be presenting to you about strain gauge resistive transducer. So before I give you guys a brief explanation on what exactly is a strain gauge, allow me first to introduce myself. Hi, my name is Sridharan, Analytical Practitioner, metric ID EL24003. And today I'll be giving you all a brief explanation and introduction on what exactly is a strain gauge. So let's start. Strain gauge. A strain gauge is a passive transducer that uses electrical resistance variation in wires to sense the strain produced by a force on the wires. Well, what exactly is a strain gauge used for then? So, a strain gauge is used to measure four main things, which is the measurement for weight, measurement for pressure, measurement for mechanical force, and also the measurement for displacement. Moving on, there are two main types of strain gauges. The first one is called bonded, and the second one is called unbonded. So, what are the key differences that differentiate these two types? As you can see in the slide, there are many differences that differentiate between these two types. Allow me to give you guys the explanation on the bonded. So, for the bonded type of strain gauge, the strain sensitive wire or foil is bonded directly onto the surface of the specimen using a special adhesive. The strain from the test material is then directly transferred to the gauge through the adhesive layer, giving it the accurate surface strain measurement. So, in what type of circumstances are bonded strain gauges favored? Well, bonded strain gauges are widely used in experimental stress analysis. So, what are the advantages of using an bonded strain gauges then? Well, one of the few advantages of using a bonded strain gauges is that it is small in size, lightweight, inexpensive, and it is suitable for static and dynamic strain measurements. So, what about unbonded then? For unbonded strain gauges, the strain sensitive wires are not attached to the specimen. Instead, they are mounted on a separate frame within a transducer. The strain is then transmitted indirectly through mechanical displacement of the frame and not by direct surface bonding. So, in what type of circumstances are unbonded strain gauges preferred then? Well, for unbonded strain gauges, they are commonly used to measure force, pressure, and acceleration transducer when repeated use is required. So then, what are the advantages of using unbonded strain gauges? Well, the few advantages of using unbonded strain gauges is that it is reusable, stable over long periods, and less affected by temperature and adhesive aging. So that will be all from my part. I will now like to pass it on to my teammate Wafa to carry on and give a further explanation about stress and strain. Thank you.
Okay, so we will continue with the next slide, which is stress and strain. So basically, stress and strain describe how an object reacts when external force is applied. So stress refers to the internal force developed within a material to resist the applied load, while strain refers to the deformation or change in shape and size that occurs due to that stress. So in simple term, stress is the cause and strain is the effect. Okay, so we will see the first one, which is stress. So basically, stress is defined as the internal resisting force per unit area within a material. So when a force acts on an object, so the material will develop internal forces to oppose that load. So if the force is uniformly distributed, so stress can be calculated by dividing the applied force F by the cross-sectional area A. So stress can be represented by sigma, and the formula for stress is stress equals force divided by area, and its unit is in kilograms per square meter. Next one is strain. So basically, strain measures how much a material deforms due to applied stress. So it is defined as the fractional change in length compared to the original length of the object. So strain can be calculated by dividing the change in length by the original length. So strain can be represented by epsilon. So since strain is a ratio of two lengths, it has no units, which is why it is described as a dimensionless quantity. Okay, next we will go through the stress and strain curve. So stress and strain curve shows the relationship between stress and strain for a material. So in the linear portion of this curve, stress is directly proportional to strain. The constant of proportionality in this linear region is known as the modulus of elasticity or Young's modulus represented by E. So Young modulus represent the stiffness of a material. So it is calculated by dividing stress by strain, and we can see that a higher value of Young's modulus means that the material is stiffer and deforms less under applied force, while a lower value indicates the material is more flexible. And lastly, the unit of Young's modulus is the same as stress, which is kilograms per square meter.
I am presenting the strain gauge, the fascinating device designed to convert mechanical motion into the electrical signal. At its heart, the strain gauge is a sensor whose electrical resistance varies in the proportion to the amount of the strain or physical deformation in the experience. The most widely used version is the boundary metallic strain gauge. The physics behind is the simple resistance is related to the length across the sectional area and the resistivity P of the material. When a wire is held under the tension, it gets slightly longer and its cross sectional area reduces, which cause its resistance to increase. Conversely, compression causes the wire to shorten and thicken, which result is the resistance decrease. But how do we measure exactly how much is the stretch? We use the value called the God factor GF. Short form is GS, also known as the strain sensitivity. The God factor is the ratio of the fractional change in the resistance to the fractional change in the length or strength. We calculate it use the formula that already show in the question. Total R is the change in the resistor, R is the initial resistor, and strain is the strain. Defined as the change in the length, total length, defined by the original length, and externally the gauge factor tell how sensitivity the sensor to movement. Sensitivity meter. In engineering application, having a high degree of sensitivity is very desirable. A high gauge factor means that even tiny amount of the strain will produce a relatively large and noticeable change in the resistance. This is important because a large change is much more easily measured than a tiny one. Without high sensitivity, we might miss the suitable vibration in the apron wing or the slight shifting of the bridge, which could lead to safety issue. Finally, let's look how we actually build and use the device. Construction. A typical string gauze consists of a fine gauze or wire grid protected by two sheets of insulation, often made of the material called polyimide. Insulation. The gauze is attached to object we want to test using strong adhesive. It is critical that the long segment of the grid are aligned with the direction of the stress to get an accurate reading. The circuit, because the change in resistance are too small, we use a specialized circuit called the quarter bridge. This step this setup uses voltage source and several resistors R1, R2, and R3 to detect the two tiny electrical shifts at the solder tab and turn them into the data we carry. That's all.
Okay, now let's move on to common type of resistance strain gauge. There are three types of strain gauge, which is wire strain gauge, foil strain gauge, and semiconductor strain gauge. For the first one is wire strain gauge. Wire strain gauge are made from very fine metal wire. Wire is arranged in a grid pattern, and they are bonded to the surface being measured. For the second one is foil strain gauge. They are made from thin metal foil instead of wire. They are more durable and stable than wire type and mostly common use in a practice. For the third one is semiconductor strain gauge. They are made from semiconductor material, has very high sensitivity, and they are more affected by temperature change. For the conclusion for this topic, a strain gauge is a passive sensor that changes its electrical resistance when force or load is applied. It is used to measure physical quantities such as strain, force, pressure, weight, and displacement. The sensitivity of strain gauge depends on its gauge factor. Strain gauge are commonly used because they are small, accurate, and reliable. And that's all from Group 1 from Section 2. Thank you and see you guys later.